Emission control system. In the past, one of the chief contributors to air pollution was the automobile. For some time now, engines have been engineered to emit very low amounts of certain pollutants. The pollutants that have been drastically reduced are hydrocarbon, carbon monoxide, and oxide of nitrogen. The Environmental Protection Agency established emissions standards that limit the amount of these pollutants a vehicle can emit. To meet these standards, many changes have been made to the engine itself. Moreover, there have been systems developed and added to the engines to reduce the pollutants they emit. A list of the most common pollution control devices are as follows. Positive Crankcase Ventilation, or PCV system. This system reduces hydrocarbon emissions by drawing fuel and oil vapors from the crankcase and sending them into the intake manifold, where they are delivered to and burned in the cylinders. This system prevents the pressurized vapors from escaping the engine and entering the atmosphere. Evaporative emission control system. This system reduces hydrocarbon emissions by drawing fuel vapors from the fuel system and releasing them into the intake air to be burned. This system stops the vapors from leaking into the atmosphere. Exhaust gas recirculation, or EGR system. This system introduces exhaust gases into the intake air to reduce the temperatures reached during combustion. This reduces the chances of nitrogen oxides forming during combustion. Catalytic converter is located in the exhaust system. The catalytic converter allows for the burning or converting of hydrocarbon, carbon monoxide, and nitrogen oxide into harmless substances, such as water. Air injection system. This system reduces hydrocarbon emissions by introducing fresh air into the exhaust stream to cause minor combustion of the hydrocarbon in the engine's exhaust. Exhaust system. During the exhaust stroke, the engine's pistons move up and push the burned air fuel mixture, or exhaust, out of the combustion chamber and into the exhaust manifold. From the manifold, the gases travel through the other parts of the exhaust system until they are expelled into the atmosphere. The exhaust system is designed to direct toxic exhaust fumes away from the passenger compartment, to quiet the sound of the exhaust pulses, and to burn or catalyze pollutants in the exhaust. A typical exhaust system contains the following components: exhaust manifold and gasket, exhaust pipe, seal, and connector pipe, intermediate pipes, catalytic converter, muffler, resonator, tailpipe, heat shields, clamps, gaskets, and hangers. Electrical and electronic systems. Automobiles have many circuits that carry electrical current from the battery to individual components. The total electrical system includes such major subsystems such as the ignition system, starting system, charging system, and the lighting and other electrical system. Ignition system. After the air-fuel mixture has been delivered to the cylinder and compressed by the piston, it must be ignited. A gasoline engine uses an electrical spark to ignite the mixture. Generating this spark is the role of the ignition system. The ignition coil generates the electricity that creates this spark. The coil transforms the low voltage of the battery into burst of 30,000 to 100,000 volts. This burst is what ignites the mixture. The mixture must be ignited at the proper time in order for complete combustion to occur. Although the exact proper time varies with engine design, ignition must occur at a point before the piston has completed its compression stroke. On most engines, the motion of the piston and the rotation of the crankshaft are monitored by a crankshaft position sensor. The sensor electronically tracks the position of the crankshaft and relays that information to an ignition control module. based on the input from the crankshaft position sensor, and in some systems, the electronic engine control computer, the ignition control module then turns the battery current to the coil on and off at precisely the right time, so that the voltage surge arrives at the cylinder at the right time. The voltage surge from the coil must be distributed to the correct cylinder, since only one cylinder is fired at a time. In earlier systems, this was the job of distributor. A distributor is driven by a gear on the camshaft at 1/2 of the crankshaft speed. It transfers the high voltage surges from the coil to the spark plug wires in the correct firing order. The spark plug wires then deliver the high voltage to the spark plugs, which are screwed into the cylinder head. The voltage jumps across a space between two electrodes on the end of each spark plug and causes a spark and ignites the air-fuel mixture. Today, most ignition systems do not have a distributor. Instead, these systems have several coils, typically one for each pair of spark plugs. When a coil is activated by the electronic control module, high voltage is activated by the electronic control module. High voltage is sent through a spark plug circuit. Each spark plug circuit includes two spark plugs, which fire at the same time. One spark plug fires during compression stroke of a cylinder, and the other fires during exhaust stroke of another cylinder, and is wasted. In this way, the electronic control module controls both the timing and the distribution of the coil's spark-producing voltage.